This is a short video, but it's just to go over Thales Theorem, which is an extension of the Inscribed Angle theorem. To understand what Thales Theorem is, let's first draw an inscribed angle whose value is 90 degrees. So here will be our first arm of our angle, and let's try and make it 90 degrees to get the best effect. There we go, seems good enough. And by the inscribed angle theorem, first of all, let's label this A and B. By the inscribed angle theorem, we know that the measure of arc AB is equal to 2 times the value of the angle of the inscribed angle subtending it. So therefore, since angle ACB is 90 degrees, the measure of the arc AB is equal to 180 degrees. And therefore, the central angle subtending this arc must also be 180 degrees. In this case, our central angle is angle AOB. But note, since angle AOB is 180 degrees, angle AOB is just really a straight line. And not only that, it's a straight line that goes through the center of the circle, which means it's also the diameter of our circle. So what does this mean? Well, let's take a step back and look at our figure ABC, or the lines we just connected. We've just made a right angle triangle whose hypotenuse is a diameter of the circle. And that's all that Thales theorem is really trying to tell us. It tells us that for any inscribed angle whose value is 90 degrees, we get a right triangle whose hypotenuse is the diameter of the circle. And I'm just writing it down to repeat what I said before. For any inscribed angle that is 90 degrees, connecting the arms of the angle will create a right-angled triangle inscribed inside the circle, by the way. I'll just put that in brackets. An inscribed right-angled triangle whose hypotenuse is the diameter of the circle. And again, the converse is also true. If we have a right-angled triangle whose hypotenuse is the diameter of the circle, we know that the 90-degree angle will be inscribed somewhere on the circle. And that's about it for Thales theorem. Pretty simple.